So this is, 4334 controls. This is not related to the controls lab. Okay, I get questions on that every single semester. Those are two separate courses. If you have questions about the controls lab, talk to the controls lab instructor that you have. Okay. All right. So plan for today. I'm going to go through the syllabus. I'm going to go through the homework and attendance guide. Both of these things are already on Blackboard. And then we're going to just talk about the basics of what this class is going to cover. And then on Friday, right? This is Monday, Wednesday, Friday class. Friday, we're going to get right back into reviewing some things and then move on to new topics. All right. So let's start out with talking about the syllabus here. Can you guys see this up on here all right? Or do I need to turn off the light or something like that? Okay. All right. So syllabus is online already. And folks online, can you guys hear me? It looks like the microphone's working, so I'm going to assume so. Yes. All right, good. As a heads up for folks online, the chat is like visible to everyone in the classroom. So just don't type anything sensitive in there, I guess I would say, or dumb. I will be trying to post the lectures online. You know what? Let's get to that a little bit here. All right, so control of dynamic systems. I'm not going to go through the syllabus in its entirety because it's like 8 pages or something like that. I just want to cover some basic things. You guys are all probably seniors at this point, I would hope, right? Maybe there are some juniors in here that are way ahead. You guys all should have a laptop that meets your requirements, right? Proctorio, I do not expect to use. That's in there just in case we need to shift towards that, but it's unlikely. MATLAB, it probably will be beneficial for you guys to be familiar with MATLAB or the equivalent in Python for some programs here. Zoom, so I am going to be streaming the lectures on Zoom simultaneously in this class. We'll talk about attendance in a little bit. Blackboard will be where most of our assignments are going to be posted, if not all of them. About the live Blackboard features, we're probably not going to end up using. And YouTube and Mediasite, there may be some videos that we throw up online there, right? Then we have, all the standard things that we've had here for a while. I'll talk about office hours a little bit later. You guys know what the important dates are here. And then there's a bunch of other handful of things here. Probably the most important thing here, again, the recorded lectures thing, which we just talked about. Okay, safety and wellness. I'm not going to cover that. Please read that on your own time because there's a handful of different links here as well. All right, so let's get into this. I'm Donald Dossimo. I'll be your instructor for this semester. My office is in ME North 215, not 214. It's across the hall from where I used to be. Our teaching assistant will set up her hours on Blackboard in a little bit. She's still getting all set up. Same thing for me for office hours. I'm going to post those hours on Blackboard along with some exceptions. In general, it's going to be Monday and Wednesday from 2 to 3 o'clock, I think is what we're going to go with here. And then also by appointment as always. So you can always just set up an appointment with me. This course is on analysis and design of control systems. It's a direct follow-up to ME 3333, which all of you guys should have taken already at this point, and hopefully done pretty well in it, because we are going to cover things that are building directly on top of that, right? The textbooks for this class, Control System Engineering by NICE. If you are planning to get into controls on any level, this is not a bad textbook to get started with. I will say, I don't think you'll be required to have this textbook in this class, so you don't necessarily need to purchase it. That's usually how I run things. But if you are interested in controls, it's probably going to be a good textbook to have for life. Course purpose, it's about controls. We'll get into that a little bit later. Expected learning outcomes. Number one that's listed here, obtain and use transfer function models of dynamical systems. You guys should already be familiar with that from ME 3333. In addition to that, block diagrams, you guys probably should have seen that before. And then the topics after that, well, stability, you guys probably should have seen, but things like understanding the importance of feedback, PID control, designing for closed loop stability, those are our new topics that we're going to be covering in this class, right? So the first, well, we'll get into it in a little bit, but we'll talk a little bit about modeling in this class, and then we're going to move to controls from there. The stuff that people are probably most interested in here, at least for the first class historically, is assessment methods, Participation and attendance, that's worth 5%. Homework, assignments, and maybe quizzes, if we need to have them, are going to be worth 25%. Exams, there'll be 2 of them, at least that's a plan, is 40% total. Final exam is 30% here. And if you guys have any questions, just feel free to stop me. Usually people do at this point. For grading, participation and attendance, we'll cover this even a little bit more again later. In-person attendance is not required, just some form of synchronous attendance, right? So a lot of you guys have shown up in person, but as you guys saw from the email, and for the people that have joined on in Zoom, you can also just watch this class simultaneously at the same time here, right? So you need to attend synchronously one way or another. Attendance is required. I'll go over how I check that if I need to throughout the semester. But the big thing is that you guys are expected to actively participate in this class, right? I don't want to just sit up here and talk for 40 to 60 minutes about controls and not get any questions, not get any responses to things, right? This is supposed to be a little bit of a back and forth to an extent, right? Participation and attendance just does exist in different forms, and we'll cover that a little bit later. If you have like anything in terms of like you get sick or something like that, let me know ahead of time. If it's for something minor, like you're sick and you have to miss a class or whatever, just send me an email. That's fine. That's not a big deal. I'm probably not going to require a doctor's note for that. Why does somebody do this at the beginning of every class? Jesus Christ. Every single time. Okay. All right. So attendance or illness stuff, just let me know. If it's for something more serious, like you're going to miss an exam, or maybe even you're like get sick before a homework is due, you need to let me know as soon as possible on that, and I'll try and be flexible to an extent on that. You need to let me know ahead of time. If it comes after the exam, right, unless it was like some sort of like major health emergency or something like that, it's going to be a lot more difficult to work with me at that point. Of course, if you miss an exam due to a university excused absence, that is okay. We can make arrangements for that, but you need to let me know well ahead of time. Well ahead of time means more than a week in advance, because I've already built the exam at that point. I've already made my plans. Quizzes may be unannounced. It's likely, unless you guys are a bad class or a disruptive class, that we won't have quizzes, but I do reserve the right to give you guys unannounced at any point, right? But usually that is probably if you guys are not participating a lot and I need to wake up the class to actually do something. Any grading dispute should be submitted in writing, email for consideration, but usually we don't get that far. You just let me know before the next class after you get an assignment back or the grades back. If you have questions about that, your grade, and then we can talk and see if there's anything that needs to be regraded for that. The big thing that I have here, cheating is definitely not acceptable. You know, you guys may work a little bit together on the homeworks and stuff like that. You should not be mindlessly doing it. I think there's at least like 2 people in this class that have taken my previous ME 3333 class before. They know that my homeworks are very reflective of the exams usually, right? So you're doing a disservice to yourself if you just copy someone else's homework assignments and stuff like that. For the exams, I'm very strict about cheating, and I hope we don't have any issues with that. But I will, if you're caught cheating on an exam, I will take that very, very seriously, and that's going to be very problematic. Grading is the standard like setup that you guys are, I'm sure, are familiar with, right? I do not plan on rounding them, so 93.00 is an A, but 92.99 is an A minus, right? Which that's the same thing for TTU. Is there a question back there? I couldn't see. All right, schedule for this class. This week, introduction, and we're going to talk about modeling and solution methods. Modeling and solution methods, and even first order and second order systems, and maybe stability to an extent. That is kind of review from ME 3333, but we're going to look at it from maybe a slightly different perspective here. But that is a lot of review topics that you guys should be familiar with. Laplace transforms, transfer functions, block diagrams, all that sort of stuff. Modeling mechanical systems, modeling electrical systems, that's a big one, and electromechanical too. Probably not thermal or fluid though. After we get through that stuff, we'll have exam number 1 somewhere around that 5th or 6th week. maybe even the 7th week if we need to shift it. This is a very tentative schedule, and I'll say this is probably going to shift. So do not go with this, especially for the exam dates. I get emails every semester about someone that says, well, the syllabus says the exam is on this date, and it's right there at the top, subject to change at any time. Go off of what I say and what's on Blackboard and through email over this syllabus outline here, the schedule. All right. After that, the first third of the class is kind of review, but looking at things from a slightly different perspective. Then we're getting into controls, and we're going to stick with those new topics for the rest of the semester after that. So we'll have a second exam somewhere around like week 12-ish, maybe week 11 if we can move it up a little. That's right after spring break. So probably week 12. And then final exam at the end of everything, which will be cumulative. Any questions on the syllabus? Seems pretty straightforward. I know it is long, but I'm going to send you guys a lot of like instruction documents throughout the semester that are long. Please read them carefully. That is going to be very important. All right, here is one of these instruction assignments or documents I was talking about. So participation, attendance, and videos. Like I said, there's several different ways that participation is going to be evaluated, right? One way is people that are like answering or asking questions in class. That's a great form of participation, right? And that's a way to get a lot of points, right? But for some people, maybe that's not their chosen way to participate. Though I would say I do prefer that, but going to office hours, asking questions through emails, whatever, have it, some sort of interaction with me that I know that you're trying or putting in effort, right? Those all count towards participation. There will be random attendance checks if I get frustrated with low levels of participation. Usually it happens, I would say around week like 8, 9, something like that. And everyone dips down and I get a class, that one class that everyone is just like not bothering to try at all. And that's the one that I end up having to do a random attendance check, and that does impact your grade down the road. Let's try and not get there. Maybe you guys will be the first class that I never have to do that random attendance check. Or maybe you guys will be the class where I have to do it like every 2 or 3 weeks or something like that, or every 2 or 3 days sometimes. But yeah, so that kind of covers that. Lecture recordings. I do not have the same resources in this classroom as I did previously. I'm still going to try and record these like I'm doing right now through Zoom at least, so we have something. But I'm not going to make any promises about this little computer doing these like 50-minute recordings, because it does get kind of burnt out. And I have lost a couple in the past, and we'll just have to adapt when that happens here. But my plan is to make these lecture recordings available online after the fact. Because students have mentioned that they do like it a lot. Homework assignments, right? This is not going to be relevant until the 20th. I think that's when we'll get our first homework assignment. There will be about 9 throughout the semester is what my guess is. They'll be assigned in class, or maybe like within the hour after class is what I should actually say in this document here. I don't always announce them in class, though I try to, but keep checking Blackboard. Like try and check Blackboard like maybe a couple hours after class, after every class or something like that, if you want to see if there's a homework assignment on there, right? But there should be about 9 of them. They will be all through Blackboard. That's where you'll submit everything. Something I really want to stress that people haven't followed this rule too closely in the past. So you're going to submit only a single PDF document to the assignment on Blackboard. Page number 1 should have your name, obviously, right? But more importantly, it should have your final answers for those problems for the homework assignment, just the final answers. And then all your work is on the other pages after that, right? Homework assignments are going to be graded based off of a combination of effort and correct final answers, right? So that first page, right, where you say what your final answers are, those are worth usually 10 to 30% of the entire homework. So it's if you get it right or wrong, and that's it, right? The rest of it, the other 70 to 90% of the homework is based off of just putting in a lot of effort to it, right? Effort is subjective. It depends on the problem, actually, for the most part, I would say. But you need to make judgment calls based off of that. But if you just put final answers and have no effort, then you get a 0 on the homework regardless. Homeworks can be submitted late, but that's only before the final answers for those homeworks are available. Usually it can be anywhere from 2 minutes after the homework was due to maybe like 2 or 3 days after. If you submit during that time period, it's 20% off. Usually the homeworks are at 10 points. So you automatically go from a 10 out of 10 to an 8 out of 10 as your highest score. Okay. Usually homeworks, you get about a week to do them as well. Any questions?
Just be posting final answers.
Only the final answers is my intention here, except for maybe some special cases, right? But I don't want to give you an entire solution manual because I don't think that's the best way to learn. If I tell you where you need to end up, I will give you guys enough in the class and in our lectures to be able to figure out to get there, right? And if not, you can come to me and talk to me in office hours for that. One other thing I want to mention, so in the past, I've kind of switched a few different ways for how I do exams. So I said you can take this class online. The exception to that may be exams. So exams may be entirely online, or I think I'm probably going to try out this semester where they are in person only exams. So maybe you guys have heard about my format in the past, but that's probably going to change. So for the folks that may attend online and stuff like that, just keep in mind for the days of exams, you're going to probably need to be here, at least for probably the first one. I want to try it out at least, but probably for all of the exams, or at least the first two. We'll see about the final exam. Okay. So just keep that in mind. Attendance for regular lectures, yeah, you can attend online. That's fine. Just give me a heads up about it if that's your plan for the semester. But for the exams, be prepared to take an exam in the class itself. Okay. All right. No other questions? All right. If not, then I need to.
The exams are we allowed in that group?
I'm evaluating that right now. I would say probably at a minimum, a study sheet, maybe even the textbook itself too. And then probably a calculator, I would bet, at least for later, maybe the second exam. Outside of that, I'm not sure beyond that point. Yeah.
Do you have specific calculator requirements, like certain ones that are allowed?
No, not really. I don't think so. Again, I'll let you know when we get closer to it, but not really. I think that's a little bit excessive, at least. We'll see. I used to do completely open online exams, but then of course there are concerns like things in the chat where people can very easily communicate in the middle of an exam. So I'm trying to filter that out a little bit. Okay. Any other questions? All right. So let's start with our introduction here. This goes through a little bit of the first chapter. Yeah. If any changes happen to the schedule and is announced in class, when you also send that through email, no, I would just probably send it in class or say it in class. Yeah, gotta come to class, gotta pay attention, right? Especially if I'm posting the lectures online. Yeah, for some special cases, sure, I may give it in multiple ways, but I can't send an email after every class for everything that I say because I'm gonna say a lot. All right. So for those that have taken my 3333 class in the past, you may have seen this flow chart I built before about the control engineering process. Now it depends from engineer to engineer and system to system, but in general, we start out as a control engineer with identifying a system of interest, right? Probably defined by whatever job you have or work that you're doing or something like that. That's probably defined what your system that you're interested in, right? Once you have that system, you're going to develop a model of the system. All right, after that, I'm going to just combine these. We're going to analyze and simulate the model. And from that, we're going to get some information that we're going to use to develop a controller. That is a core feature of this class here. That is a big feature of this class compared to 3333. And then sometimes you may need to iterate. You may even need to go further and further back, right? But this is the general control engineering process, right? having a system, getting a model for that system, analyzing that model, and using that information to develop a controller. So let's go through each of these just as a review. Our system is a combination of elements intended to act together, usually to accomplish an objective. Right? You can think of it as components combined together, right? So like, I'm going to use probably cars as an example. Cars and batteries are going to come up a lot in this class, just because that's what I work on. So we're going to use that a lot as an example, right? But say a car powertrain, right? Like a battery and a motor working together, that is a system. Some people would argue that a battery on its own is a system, right? Some would argue that a battery cell on its own is a system, right? There's different definitions of it. We won't get caught up too much in those kind of those smaller details, right? But a system is some combination of elements where that elements is a little bit of a vaguely defined thing, right? So for now, I'm just going to draw a system as this big cloud thing with a boundary to the environment. I think a lot of you guys have probably taken thermo already, right? Heat transfer as well, yes? How many of you guys have taken heat transfer? All right, good. So a vast majority of you guys, right? Kind of like a control volume, right? That can be seen as like our system that we're working with. Our systems will have inputs that go in. All right, so these are our time-dependent variables. That cause things to happen. All right, there's different forms of inputs. In this class, we're going to tend to focus on control inputs, often represented as u as a function of time, or just u, I'm going to use very often, right? Are user-defined inputs. So this can be extended to something that a computer is controlling, right? And then we also have, in addition to our control inputs, exogenous inputs, also known as disturbances. Can be represented as a W or a D, right? These come from external sources. All right. In addition, our system has outputs. Now, outputs are not the things that are like, inputs are not only the things that are entering a system, and outputs are like leaving a system, like say a pipe system, right? It's not like that, right? An output is a time-dependent variable, or they are time-dependent variables that show the effects on the system due to the inputs. In this class, we're going to distill this down. These are measured things represented by a y or a y of t, right? So our outputs are like the things that we're measuring, the things that we're paying attention to, right? How hot something is, how cold something is, right? Like temperature, that is something that we can measure. Velocity, something that we can measure. All right. A system also has things that are going on inside of it itself, right? It has inherent properties. Those are our parameters. For this class, usually our parameters are going to be fixed values for a system, like the mass of something, right? Mass of a vehicle, that is a parameter. It's not going to change, at least not by a lot, right? There are also states, right? States depend on not just our most recent input, but past inputs as well, right? That is the memory in our system. It is usually related to the storage of energy or the storage of mass from conservation of energy, conservation of mass, things like that, right? We're not going to focus too much on states in this class, but hopefully you guys are familiar with those at least a little bit. All right. Any questions so far? Yeah. Last type of input is exogenous inputs or disturbances, which are represented by a W or a D. Through the video, right? We're recording the video for a reason, so you'll just have to go through the video itself. Other questions? All right. Can somebody give me an example of a system? I already said car. HVAC? Sure, that's a pretty generic one. But HVAC systems are definitely very common ones. What else we got? Nervous system, that's a good one. That's usually there's like one person I've started to notice that talks about biomedical or biological systems. Those are interesting. I know zero about them, so we're not going to talk about them in this class, but they definitely are applicable to this. That's what my PhD advisor actually does now, is controls as it relates to biomedical systems. Amplifier? I think you can make an argument. Wait, what kind of amplifier are you talking about? Because that actually has a different context in this class. Yeah, you're talking like actual like music type stuff, right? Amplifier actually means something else in this class when we talk about op amps, right? Just amplifying signals, but same concept, right? Yeah, I would say that's a system. Other stuff? Plane, sure. Come on, guys. This is the easy part where you guys get engaged in the class. Smartphone, I heard. Sure. Stereo system, that's kind of similar to amplifier, but I'll take it. Sure. Say again?
Speaker.
I can't hear. Can you type it in the chat? Yeah, that's the other thing with this laptop. I can't really hear things very well. Speaker. God. You guys are not very creative. Okay. All right. At least you're trying. Okay. Let's go with the car here. Give me examples of control inputs, of exogenous inputs or our disturbances, and our outputs. Pistons, climate, weather, natural systems count. Yes, I would actually argue that you could say those are, for sure. So I'm writing a paper kind of relating to that right now. And pistons for sure, though I probably just would have gone with engine. All right, control input for a car. Any ideas? Steering, right? Steering direction or whatever you want to have, steering angle. Throttle. What else we got? Brakes for sure. I would not say that is a input to the system, or not a control input is what I would say, because that's not something that, I mean, I guess if you're talking about in the context of like filling up a car, right? Then I guess you could argue that is a control input, and there are like research problems out on that, like minimizing the amount of time to fill a gas tank or charge a car, right? So you could make that argument actually. A little bit different than the context I was going for here, but not a bad idea. Windshield wipers, sure.
Like a shifter.
Yep. Wipers that I can't spell. Whatever. So ABS braking, I would say that is still the brake is what's controlling it, right? And then there's an internal system that's actually like more acting on that. Not a bad idea, but maybe not quite what we're going for control inputs, right? Gas pedal, brakes, steering wheel, those are probably the most common ones, right? What about exogenous inputs? Air resistance, I would go with like, let's say wind, right? But sure, something like that, right? That is something coming from the outside, right? That's potentially time varying. that is going to impact the dynamics of our system. Another car coming for the other direction. Sure. For autonomous vehicles and trying to avoid collisions, I'd say, yeah, sure. Yeah, why not? What was uneven terrain? So like the road, other cars, that's a clever one. Was that? Load? Usually you're making that decision on that. Like it depends what you mean. Load is a very generic term. So incline relates to the road is what I would say, uneven terrain. Though they do kind of have a different context. I would kind of group all that together. Towing, usually you're making that decision of like adding it, and then it is part of your system is what I would say. I don't know who's answering this. I can't see. There's so many people in this class. There's someone over here. Yeah. Maybe I would still argue that you probably should model that as your system itself, though, because that is something that's it depends where you draw your control boundary. So maybe you could model as an external force for whatever shifting in there. Maybe. Yeah, I would consider that within the road as well, right? So like driving over snow versus driving over bumpy roads, sand, stuff like that.
And animals are like.
Sure. So I guess objects.
But like.
Yeah, I would say that you could make that argument. It probably would impact more your HVAC system in the car than other things, right? But why not? All right, what about outputs? Velocity is definitely the big one, right? Any other outputs? That's definitely the most major one. I heard, so displacement, that's probably, yeah, I guess you could say displacement. So distance traveled. Power, maybe, if you measure that. Torque, I don't know how many cars actually have torque sensors built in there, though. So orientation. So do you guys, like, those could be outputs. Do your guys' car have those, like, on the dashboard? Has acceleration? Who said? Yours does have acceleration on it? All right, so that's a good one. RPM, right? Temperature of what's in the cabin of the car itself, if you're including that part of your system, right? Anything that you can measure, really an output can be more than what we measure, but for now, we're gonna just say things that we measure. Easier to wrap our heads around it. Does exhaust count? Such as a system you were looking at was based off of emissions, potentially, right? Again, probably most of our cars here probably don't measure that directly, but if you work for the EPA or another agency, or even a car company, that is something that you probably have a device that measures that type of stuff when you're doing tests. So why not? All right, so we're through the system. We still got 15 minutes left here, so. All right, so we're gonna use the car moving forward here. Let's say we work for a car company. And our customers don't want to drive themselves anymore. I don't know about you guys. I am ready for autonomous driving to be here. I would love to give my hands up and not, like be able to do other things than actually driving and paying attention to the road, right? So how can this car company that we're working for adapt for the age of autonomous driving here, right? So that's what our end goal is going to be, is we want to do some sort of autonomous driving here, right? So what's our next step here? We have a model, right? This is often a mathematical representation of the system. Could be graphical too, could be a few other things. We'll just go with mathematical because that's what we're going to focus on. All right, so we have very basic car here. Right? We want to get a model for this car. So, ideas for how we would get a model for a car.
Probably some sort of force balance.
Okay, right. Do you know what that's called? Force balance, free body diagram is relating to this, right? At least for how you guys learn it. That's too complicated. Now you're going too far the other direction. I'll keep it basic with me. Newton's second law, right? That's what you're saying, force balance, right? So let's use Newton's second law where we'll pretend this car is just a point mass, right? But we want to get a model based off of Newton's second law, right? So what forces are acting on the system? Gravity, good. Friction and drag. So I'm going to just group them both here together, right? But those are both, right? Air resistance, sure. Wind, I'm going to categorize into drag. Normal force, sure. Was it? Width? Weight, that's still part of, that's gravity, is what I'm saying here. That's actually weight. Yeah, so same thing. What else? Right, propulsion. We need this car to move forward. So some sort of propulsion or thrust. This is a point mass model. We're only moving in one direction here. So we probably don't need to worry about any type of oscillations or anything like that. We don't have a suspension system. We don't have anything like that. That's what you're talking about. These are things that we absolutely can model. Would take us probably 2 or 3 classes in this class just to get to that point where we can model something so complex. But if you're working for a car company, you are doing something like that, where it's not just a point mass, right? Okay, so we can get a model for this system, right? How many of you guys know what a state is? Just out of curiosity, in the context of controls or 3333. State, no, specifically a state or a state variable. Show of hands, how many of you guys know it? People that were in my class better raise their hands. We spent an entire semester on it. That's very disappointing. All right. State for a vehicle would be its velocity. It is the thing that we don't have direct control over, right? We can't just say for any sort of mass to change its velocity, right? You can't just instantly change a velocity from 0 to 1 or something like that, right? It takes energy to make that happen, right? A mass has kinetic energy, right? Kinetic energy is relating to the mass of the system itself, right? And its velocity. The velocity, the thing that's related to the energy stored in a car, in this case, it's storing kinetic energy, that's velocity, right? We'll talk about that a little bit more here in probably a week or so, I would say. We'll review that stuff very quickly. We're not going to deal with states too much, but that is the thing that we're going to relate to our differential equations here, right? We're probably going to have some sort of acceleration, the derivative of velocity in our system, right? We also have, so this was our state, our parameters. What are some parameters for a vehicle? What do you think? Safety, you're thinking in terms of design parameters now. Mass is what I'm going for, right? Things that are more inherent to the vehicle itself, right? It has a mass, right? It probably has tires with certain like rolling resistance conditions and things like that, right? Mass is probably the basic one that we're going to focus with here, right? There are a lot of different parameters for our system, right? These are typically the ones that are fixed or very slowly changing over time. Okay. All right. We have a model for our car. Remember, we're trying to build something that is going to control this car autonomously.
Would the power capability be a parameter in the sense of
That sounds more like a design feature, right? And actually, that's going to tie into the next thing here. So that's actually a good segue. Analysis and simulation. Right. In some contexts, yes, power, especially for like a motor, could be seen as a lumped parameter in a sense, like max power or something. But let's focus on just like our standard, like second order or first order model that we have for our system here, right? With a known model, you can determine certain features and characteristics of the system. Right? That could be power, right? Maybe some sort of power metric we can determine from our model, right? Or from simulating it. So even more simplistic than power, right? Example for a car, right? Probably the most standard one, 0 to 60 mile per hour time, right? Do you need to build a car in order, do you need to have the car and physically test it to figure out an approximation for what this is? No, if you build a model that closely captures this car, you can simulate it or analyze that model, right? And determine an approximation for how long this car with so much mass and so much drag in certain conditions will take to go from 0 to 60, right? We do not need the actual physical car itself for this, right? Which is going to save us time and money, right? Could you imagine if you're going through a car and you're trying to sweep how many different masses that you could have for it, right? Do you want to physically test that, adding 1 pound at a time on that car and then testing it 0 to 60 miles per hour? No, you just simulate it and get a good approximation for it. And then you can experimentally validate it later on, right? So 0 to 60 mile per hour time, you can approximate that either through some analysis, right? Figuring out the eigenvalues of your system, I guess, if you want to say, or you can also run tests by simulating virtually. Run tests by simulating virtually, or solving it analytically if we have the capability of doing so, right? Under certain inputs and disturbances. All right. So now we've learned a little bit more about our car, right? We figured out, how fast it can accelerate under certain conditions, right? That can provide us a lot more information. We're now at the last stage, right? And this was our objective all along, right? We wanted to build some sort of controller, right? Some sort of way to autonomously control this vehicle, right? So we don't have to drive anymore because that's what our customers want, right? Controller, essentially, how do you decide values for the control inputs at any given time? All right. So what's an example of a control system that we have in our cars now? Or let's even go back like 10 or 20 years for people that don't have as nice cars as someone who's measuring their own acceleration and stuff like that, right? What's a common control system that we have in our cars? I heard cruise control, which is the one that I was looking for. Traction control is also, that's a good example I didn't think of before. But cruise control is the basic one I'm looking for, right? Because that one can very obviously lead to autonomous driving down the road, right? I think some more cars now, they have like lane keeping assist, right? They have the more advanced cruise control where it can actually follow vehicles and stuff like that, right? We can kind of see that evolution for where we're going towards autonomous driving, right? So the question is, how do you do control, right? How does your vehicle figure out how much the throttle should be on, right? Or how much you should be pressing on the brake automatically without you having to do it, right? You just set a velocity and you say go, or you say follow this car and it just goes, right? How does the vehicle figure that out? Okay, what were you gonna say? Let's keep it simple. Let's just go with cruise control for now, right? So taking environmental inputs, I would say maybe you're measuring the external, like the disturbances, right? But what else are you taking? Your measurements, right? That's what we were using before, right? Those measurements are important, right? We need to know what velocity we're going at now in order to make decisions, potentially, right? And this is the last thing we're going to cover for today. So there are two types. Well, there's many types of control, but we're going to talk about two: open loop control and closed loop control. So open loop control, we have one more type of input. We had control inputs we had exogenous inputs. Now we also have reference inputs. Right? I want my cabin temperature to be 25 degrees Fahrenheit, right? I want to be going 70 miles per hour, right? Those are your references, what you're trying to do, right? Open loop control, or at least one form of it, you send those reference inputs into a controller, right? Some sort of like computer, some sort of algorithm, an Arduino or something more advanced probably, right? That controller is going to take in that information and say, okay, if I want to be going 70 miles per hour, then I need to put in a throttle of so much, right? And so that controller spits out a signal, our control inputs, or control input in this case, that says, all right, put the pedal at position 33% or something like that if we want to go 50 miles an hour, for example, right? That will go into our plant or our system. We're going to refer to it as both of these throughout the class, right? System is going to be kind of generic. But plant is referring to the car, the physical system that we're dealing with. And then we get our output, how fast we're going, right? This is a form of a simple controller, right? It's kind of like a lookup table. Say, I want to be going at a certain speed. Let's just find what control input I should have for that and just throw it into the car, right? What's the problem with this though? It's not going to be very smooth. Well, maybe that's very possible, right? What else? That's actually a good point. No iteration, we'll get there in a second, but why do we need iteration? If this is a great controller, we don't need iteration, right? That's kind of relating to the iteration thing, so we'll get into that in 1 second. What happens when we have our disturbances, right? The things that we don't exactly know what's going on here, right? Sometimes disturbances are noise. We don't necessarily know exactly what they're going to do, right? And if that happens, then that's going to affect what our control input could be. I should really have them summing together or something. That's usually how you present them. I'm just going to have it go into the plant itself, right? So if you get a gust of wind, right, that's not something you can measure usually ahead of time, except in certain scenarios, right? Then suddenly your controller is probably not going to be going the velocity that you thought it was, right? Unless you measure that wind as well, right? Or that wind speed. So what's a smarter way to do things usually? Closed loop control, which people are starting to touch on here. So closed loop control, we have our reference input. That goes into our controller here, right? Which we'll get into, that's what we're doing in this class, is designing that to spit out our control input into our plant or our system. Even with those disturbances coming in, we get our output. And then what do? We send this output back into the controller so it can check. Am I going the speed I want to? No? Okay, maybe I need to ramp up or slow down a little bit, right? Maybe I need to increase my throttle a little bit. Maybe I need to decrease it, even with the effects of those disturbances here. This is one form of closed loop control here, right? And that's what we're going to be focusing on for this class once we get through our modeling and reviewing all that sort of stuff here. That is the objective for this class. Any questions? All right, that is it for today, folks. Friday, we are going over Laplace transforms. We are only going to spend a day or so on it. Please make sure you're familiar with it.